Hi, this video will show you some introduction to integration. Let's look at this table for the derivative and also the antiderivative. Antiderivative is also called as integral. So for the derivative, let's say we differentiate the x squared function, we get the 2x. And if you continue to differentiate the x squared plus 1, since the 1 is a constant, we will get 0. Okay, the remaining answer is 2x. And for any constant, basically you will get 2x as well. On the other hand, for the antiderivative, we have to integrate both sides. So in this case, on the left hand side, we get x squared plus c because the differentiation and integration can be cancelled. So with that, we obtain the x squared plus c here. Well, on the right hand side, you get the integral. So this means that we are doing the opposite of derivative. In this course, we must master how to do the derivative or integral for some basic functions like polynomial, exponential function, trigonometric function, inverse function for the trigonometric, inverse function for the exponential. For example, for the polynomial function 1 and 2, you should know how to differentiate them to get this answer, and also you should know how to integrate them to get this answer. And for the exponential function, the answer for derivative and integral is in red color. Green color is the derivative and integral for the basic trigonometric function. And lastly, so these two is the inverse function result. You must know the difference between indefinite and also the definite integral. Basically, the definite integral is the one with limit, and indefinite integral is the one with no limit. So for example, you can see the integral function here with no limit. So this is called indefinite integral. Well, if you have something in limit, this is called definite integral. The answer for indefinite integral with constant and a function. But on the other hand, definite integral have limit here where you have to substitute inside the function gx to obtain gb and minus with ga, which gives you a finite answer, which is a number. For example, if you have a function 1, you want to integrate 1 with respect to x, we get the answer in x, and don't forget your constant. So to find this constant, you have to know the initial condition. So for example, if let's say I give you the initial condition is this: when your x equal to 0, your y will be equal to 0. So we substitute inside when x equal to 0, your y equal to 0. With that, we obtain the c to be 0 as well. So in this case, we can let this to be 0, and at this condition, the y is equal to x only. On the other hand, for the definite integral, let's say I have a function y equal to x here. If you take the differentiation dy over dx, you will get a constant 1. So if I ask you to find the area within 0 to 5 for this function, you will form an equation like this. Integrate from 0 to 5 for the function fx. So in this case, your fx is equal to 1. We substitute this to be 1. So let's try to solve this problem. So y is equal to this. So 1, after we integrate, we get x, and the lower and upper limit is written here. Substitute your upper limit 5, you get this, and minus with the 1, substitute with lower limit 0. In the end, you get 5. So this answer is the area where we can check Okay, so from here the height is 1 and the width is 5. So the area is equal to 5. This verifies that we can use the integral function to find the area. So in this slide, we show you how to differentiate and integrate a function which involves the indefinite integral. So let's say we have a function y here, and if you plot, you get this graph. So let's assume that this y is our displacement. So if we want to get the velocity result, we have to perform the differentiation, and we get the velocity data. So this is our velocity, and if I provide you the velocity data, and I want to obtain the displacement result, in this way you can perform the integration. So please take a note that after you integrate, there is a constant which is unknown. To find this constant, you have to apply the initial condition. So to know what is the initial condition, you can look at the original function here. At x equal to 0, you know that your y is equal to 1. Therefore, we substitute this information into the integration result. So y is equal to 1 when x equal to 0. So with that, we substitute the x equal to 0. All of these terms will be 0 as well. And this c is remain. So your c is equal to 1. So instead of a arbitrary number where you can see you can put the c to be any number, from the initial condition, you know the actual result to be c equal to 1. So the blue color is your final answer, which is the actual solution. So this is the general function for the definite integral, where you have lower limit a and upper limit b, which is shown in here, and you have a fs function as the integrand, which is this one, and the integration is integrated with respect to x-axis. So by solving this integral, basically you are looking for the area within this region. So if I ask you to find the area within this region, you can solve it using this integration. Here are some examples where you can apply the integration method in solving some engineering problems. So let's say for the first case, the surveyor wants to know what is the area within this region. He can solve it using this formula. As long as you can know the lower limit a and b, which is these 2 points, and also the function fx, which is this curve. So same to the water resource engineer who want to know the area for this depth, okay, for example. So he can use a similar formula to solve it. So as long as you know the function fx here and define the lower and upper limit properly, then you can get the answer. Lastly, if you want to find the, let's say in this case, structural engineer, you want to know what is the net force acting on this tower. Okay, so for the net force is the summation of all the pressure acting on this region. So you can see that for this curve is a function with respect to y-axis, and your limit a and b are in y-axis, therefore your integration is in y. So this is your scope of the study. So please make sure that you are able to understand the difference between the analytical and the numerical integration or the differentiation. So our focus will be the analytical integration, where the numerical part is not covered in this study. Then you will also learn about the strategy and method to perform the integration. We will make the revision on the basic integration rule, integration by part, substitution, such as the one with triangle substitution, like this, and then partial fraction, like the one highlighted in the, and also lastly the The other techniques such as factor, completing the square, and other.